So having heard from a couple of industry viewpoints, we now have Keith Stouffer from NIST, National Institute of Standards and Technology in the U.S. Keith is the lead author of NIST's special publication, The Guide to Industrial Control System Security. This is an area that Keith has worked in since the year 2000 at NIST, and so he has really deep expertise in the subject and has provided input to various international standards bodies. Standards are going to be important not only for implementing best practices within each company, but for the business relationships and the trading partners that we deal with so that we can have common expectations as to the risk. Large companies worry about their smaller suppliers and don't want the small suppliers' vulnerability to become their vulnerability. And so in the U.S., we're all looking to NIST to help us collaborate and develop solutions. So please welcome Keith Stouffer.
Well, good afternoon, everybody. Thank you all for hanging in on the last afternoon of the last day, and thank you, Mike, for the introduction. And I'd like to thank the World Manufacturing Forum and IMS for the opportunity to present at this event. So what I would like to talk a little bit about today, so the previous two speakers spoke about some of the concerns and threats that manufacturing systems have. So what I'd like to try to do in my presentation is to provide you some guidance on how to secure your systems, some resources to get additional information on securing manufacturing systems to help protect yourself against some of these threats and security concerns. So what was our strategy when we started working on developing standards and guidelines for industrial control system security or manufacturing security? Well, the first thing that we did not want to do was reinvent the wheel if we didn't have to. So what we wanted to do is look at the already existing risk management, security risk management frameworks that are currently out there. Figure out, can we modify those, provide additional guidance so that they can be applied to the manufacturing environment. Some of this information can take the form of specific cautions when applying certain security controls, and essentially just in general how to implement security within the manufacturing environment. The two documents and series of documents I'd like to talk a little bit about more are the one that Mike discussed, NIST Special Publication 882, which is essentially an implementation guideline on how to secure industrial control systems and manufacturing systems. And then an international series of standards, the ISA IAC 62443 suite of security standards for industrial automation and control systems. So NIST 882. What it does is provide guidance for securing manufacturing systems while addressing their unique and demanding performance, reliability, and safety issues. You heard it was brought out this morning, especially in the robotics session, that safety is very important in these systems. And you heard from the previous speakers that reliability is key, and so is performance. These systems often run 24/7, 365 days a year. So 882, what it does is it provides an overview of what industrial control systems are, so that people, especially in just the IT environment, get an understanding as to what these systems are, how they're different from normal IT systems, how to perform risk management and assessment in this manufacturing environment. You heard earlier in the sessions today, and again in the robotics session, risk management is very important. It defines how you're going to secure your systems, how to develop and deploy a security program for securing your manufacturing systems, how to architect your system. Again, how to apply security controls to these manufacturing systems. What are some of the current threat sources, vulnerabilities, and incidents that have happened in manufacturing and industrial control systems? It gives you an idea of the other current activities that are going on, so you can get, so you can go and look and learn from other activities in the area. Provides a list of capabilities and tools to especially help you do vulnerability assessments, particularly in the manufacturing area. And it includes 3 starting baselines of security controls to start with in implementing security in the manufacturing environment. We've been working on this document with the community, both the public and private sector, internationally since 2006. I'll talk a little bit about more later. We're currently in revision 2 of the document, and it's probably one of the most heavily referenced ICS security document in the world. It's been downloaded over 2.5 million times since 2006. So real quick, I'm not going to go through these in any detail. What are some of the major security objectives that you want to try to accomplish within your manufacturing systems? You want to restrict logical access to your manufacturing network and network activity. You don't want to have what's called a flat network. You want to have as many hurdles as possible trying to get down to the core of your manufacturing system, that real-time part of your manufacturing system. You want to make sure you restrict physical access to your devices, because a lot of these devices, once you have physical access to them, you can do anything that an authorized user would. You have complete control over these systems, so you need to protect the physical access to these systems as well. You want to protect the individual components from exploitation. Galena mentioned about how you do security patching within these systems, disabling unused ports and services. I mean, do you really want a web server running on your software PLC? Things like how you implement antivirus down on some of the newer types of systems. What's also very important is maintaining functionality during adverse conditions. Unfortunately, no security program is going to give you 100% security. So you need to, unfortunately, plan for, if there is an incident, how is the system and how are you going to respond and recover from that? More importantly, again, based on risk to your system, deploy a security solution based on potential impact. There's not a one-size-fits-all solution to that. So what does that mean? So NIST has 3 levels of baselines to start with: low, moderate, and high. But what does that mean for manufacturing systems? So real quick, I want to tell a quick personal story to help you visualize this, and then we'll get back to security. So I have 2 children. They're 15 and 13 now. And several years ago, I was thinking about, it's like, I want to get the kids involved in a hobby that involves science and engineering, but will be fun as well, and that I would enjoy, that they would enjoy. So I was thinking, what can I do? And I came up with model rockets. So I'm not sure how popular model rocketry is outside of the United States. Who here's built and launched a model rocket before? Not many people? Okay, so this may not work so well. But these are little Estes rockets. They're made out of cardboard and use small little engines. So they fly up a couple hundred feet, and if the parachute doesn't come out, it's not really too much of a big deal. So they fall down, not really too much of a chance of a big impact. So what's that mean for control systems? Now we're talking things like maybe non-hazardous materials, non-ingested consumer products, for plastic injection molding, warehouse applications, where your security concerns are mostly about protecting your people, your capital investment, and ensuring uptime. So after a while, we started doing some searches on Google. Google is a great search engine because it can cost you money. And I found out that things have changed a lot from when I was a kid and was launching model rockets. So we started building bigger, what are called high-power rockets. And that's how I normally dress. With these types of systems, these types of rockets, if something happens, the potential impact is a lot bigger. So you want to have more security controls in place to make sure like the parachute deploys. So for manufacturing systems, that's maybe have some hazardous products or chemicals during the production, maybe some proprietary information you're trying to protect. Industry examples may include automotive, pulp and paper, where there's a lot of chemicals, semiconductors, where your security concerns are mostly about protecting people, trade secrets, capital investment, and again, with all these systems ensuring uptime. So within the club that I'll launch at, there's some people building some pretty big, still model rockets. So this is a 3/4 scale Patriot missile. It's not a real missile. It's still just a tube that has an engine in it. But now, with these systems, if something happens, it could be pretty bad. So you might want to have redundant electronics to make sure that your parachutes deploy, and a lot more security to it. So one more here. So here's one. As we say in the club, that he got the up part right. The down part didn't work out so well. And there's the high impact that we're trying to avoid. So now for control systems, we're talking about critical infrastructures, hazardous materials, ingested products, military components, things like utilities, petrochem, food and beverage, where people are consuming things, defense, where the security concerns are mostly, ensuring basic social services, protecting human life and the environment. Now, one more before I move on. So our club is probably 3 or 4 years ago in Maryland, built the world record largest amateur rocket that was built and launched. Now, I don't know if people are familiar with this. This is a 1/10 scale of a Saturn V. Saturn V is what was used to put people on the moon, unless you believe what they said this morning believe the conspiracy theorists that we were never there. So the Saturn V was 110 meters high. So this is the 1/10 scale of that. So it's 11 meters high, which is pretty much about the size of this very interesting sculpture that's out in front of the building. And it weighed 750 kilograms on the pad. So there's a picture of it ready to go, and it was successfully launched and recovered. So 882 Revision 2, what's the schedule for that? It is currently out for international public comment. It is through July 18th, so there's about 2 weeks or so left. We are really, NIST tries to work with everybody possible to gather information to make these documents as beneficial to the community as possible. So please, if you haven't had a chance to take a look at the document, take a look at it, provide comment and feedback to us. If you think 2 weeks is too short of a time, once this initial round of comments are resolved, we'll put another public draft out, hopefully around, I'm shooting for like the September time frame, which will be out for 30 days as well. And then the document will be finalized in the end of this year. So I want to talk about some of the standards that are being developed in this area. So one of the main groups developing standards for industrial control system security is ISA 99. That includes all the major manufacturing sectors, from chemical processing to petro, food and beverage, energy, pharmaceuticals, water, and like discrete manufacturing. ISA 99 works with IAC to co-brand the standards that are being developed as ISA IAC 62443. It's an international suite of standards that are being developed by 3 different groups: the ISA 99 group, the IAC TC 65 Working Group 10, and then ISO IAC JTC 1 SC 27. So I'm not going to go through these, but I just want to show you that the ISA IAC 62443 is a suite of standards that provides guidance and standards for all the parties that are involved in securing manufacturing systems, including the users, the owner-operators of these systems, the system integrators, and the vendors as well. One thing that we're doing at NIST now is we're hearing from the community that now that these standards are being developed, they're out there, people are starting to implement them on their systems. There's still a lot of concern on how these standards will affect the performance of their manufacturing systems. Is it going to negatively affect the performance of our systems? So what we want to do at NIST is we're putting together a test bed with various industrial control system manufacturing scenarios, start implementing these standards, the ISA, IEC 62443 standards, and NIST 882, measure what the performance impacts are, and then provide guidance back to the community then on how to implement these standards on their systems without negatively impacting the performance of their systems. Once we do that, then what we would like to do is start essentially stressing the systems, attacking the systems with those security standards in place as they are written to determine how effective they are against various attacks. Then we can go back to the SDOs, the Standard Development Organizations, with the information that we've come up with to determine, do we need to revise these standards to address these new threats. So what are some of the test bed scenarios that we're going to be doing within this test bed? We're going to have a continuous process scenario, which will be chemical processing and oil and gas refining. All the scenarios within our test bed, we plan on having real control system hardware and software. Some of the actual processes themselves will be simulated or emulated, but the controllers will think that they're interacting with the real system. We can't have a chemical processing plant within my little lab at NIST, but we can have, so some of the things that are real throughout are some of the new advanced manufacturing processes, including additive manufacturing that you've heard a lot about in the past few days, and robotic assembly. We also have more distributed operation types of systems. One is smart transportation. So how do we secure new vehicle-to-vehicle communications, vehicle-to-infrastructure, vehicle-to-manufacturer type of communications, and also things like smart grid and gas and water pipelines. So with that, one of the main things that everyone's been stressing within this forum is collaboration. So with that, I'll give you this key takeaway. From what we've seen, the most successful way of securing your manufacturing systems is to engage in a proactive, collaborative effort between a lot of different groups. So the management team, the managers within your organization, the controls engineers and operators, the IT organization, and a trusted automation advisor, your vendors. The team should look at all the different information that's out there available, all the best practices and guidelines on how you secure their systems and work through the process. And with that, I have 30 seconds left, and I will end.